Hello there, GED math students or any math student that's watching my video. Actually in this video I'm going to go over the basic concept of slope. And if you're taking the GED math test, it's important that you have a good understanding of slope because there's many questions about it on the test. And in your algebra class, you're going to see this a lot as well. So let me just kind of introduce you to the concept of slope. Slope basically measures steepness. Now it can take on different forms as you study it more, but for this video, let's just focus on the fact that slope measures steepness. So based on that quick definition, what do you think, or which line has a greater slope? Do you think it's the purple line or the green line? Well, I'm basically asking which line appears to be steeper. So if I were to climb this line, right? This is me and this is me here, right? Which line is steeper? Well, hopefully you can see it's the purple line. This is more difficult to climb. The green line is not as steep. It doesn't increase or go up as quickly. So if I were to ask you which line has the greater slope, it would be the purple line because it's simply more steep. Now, don't get that confused with the concept of length. The green line is longer. It has more length than the purple line, but slope deals with steepness. So in this situation, the purple line is more steep. Now, there's a couple other things I know about these lines, and later in the video I'll show you how to attach numbers to the slope. But right off the bat, I can tell that both these lines have a positive slope. And how do I know that? Well, whenever you are trying to figure out if the slope is positive or negative, you simply see how the line is slanting from left to right. And you always read a line from left to right, here to here, here to here. It's kind of like reading text. At least in English, when you read text, you read it from left to right. So you're going to read these lines from left to right as well. So as you can see, this one goes up. It increases or goes up from left to right. It slants up from left to right. And this also slants up from left to right. So I can tell right away that the slopes of both these lines are positive. Now, let's just look at a slope that's negative. It would, I'll just reposition this green line. If I were to make this slope negative, I would just kind of reorient it. And now the green line, the slope is negative because it's slanting down from left to right. So if the line is oriented in this way, it has negative slope. If it's oriented in this way, it has positive slope. So hope that was helpful. And I just want to show you a couple special cases with slope. Let me delete one of these lines here. Let's say we have this purple line right here. And it's just perfectly horizontal, it's flat. Do you think this slope would be positive or negative? And this is a special situation. Well, this is neither positive or negative. Let's say I'm standing right here. And remember, slope measures steepness, right? So this really doesn't have any steepness. Excuse me. If this is me, right? I'm not. It's just flat, right? I mean, it's not slanting up or down. It's just flat. So this has neither positive nor negative slope. And actually, this is in this situation, the slope here would be 0. And I'll get more into this later in the video. And the other special case is you could have the line oriented this way. I think I changed the color of this, but that's all good. It was originally purple, but it's all good. All right. So let's say it's perfectly vertical this way. Perfectly vertical, straight up and down. Do you think the slope here is positive or negative? Well, again, this is neither positive nor negative. Because if you were to climb this, it's impossible to climb this. And of course, I mean, you could have special equipment to help you climb this, but when it's situated in this way, it's the slope is undefined. That's how we would describe the slope of this vertical line. So those are two special cases, and I'm going to get more into that later in the video. Let's go to an actual example where we want to attach a number to the slope. I want to actually know what the number is that goes with the slope. We're actually going to measure the slope of this line. Now, before I do that, do you think the slope of this line is positive or negative? This line here in blue, this one here. Hopefully you're thinking it has a negative slope because it slants from left to right. If you read it from left to right, it's slanting downward. It is decreasing. So I know when I actually measure the slope, my answer has to be negative. So that's going to help us. But how do we actually attach a number to the slope? Well, what I do is, if you notice, there's 2 points that are given on the line. And I'm going to make what's called a slope triangle. And keep in mind that this is your x-axis, goes across, and this is your y-axis. Now, the slope, real quick, let me give you the one-way slope is defined. There's many ways, but this is the essence of slope. It's the change of y divided by the change of x. Now, in math, we don't like to write all these words. We like to write symbols. So instead of slope, usually in a textbook, it'll be written, we will use the letter m. And you're going to see this m in this equation if you studied it. Y equals mx plus b. I'm just focusing on the m piece of this equation, but I'm not going to get into this equation in this video. I just want you to realize that the letter m represents slope. Why is it the letter m? I'm not 100% sure, but just remember m represents the slope. Now, you're going to see a couple other symbols in your textbook as well. Instead of writing the change of, in mathematics, the change of in algebra, change of, is represented by a triangle. Isn't that interesting? So in algebra, when you see a triangle like this, it means the change of. So just keep that in mind. So I'm going to actually rewrite this formula here. Instead of the change of, instead of writing that out, I'm just going to put the change of y divided by the change of x. And this is the kind of formula I'm going to use for this video. All right. So keep that in mind. I'll clean all this up, and you will see it in a textbook this way many of times. Slope equals the change of y divided by the change of x. Well, how do I figure out what the change of y is? What you do is you make a slope triangle. And I'm going to take these 2 points that are in black right here that are on the line, and I'm going to connect them with a triangle, a perfect right triangle. So I'm going to start at this point. I always like to start at my leftmost point because I read from left to right. You don't have to do it this way. I just think it makes it easier. So I'm going to start at my leftmost point, and then I'm going to move this way. I'm going to move down, and I'm going to stop, and then I'm going to move across. And if you notice, I connected these 2 points using a right triangle. It's called a slope triangle. And when you're making these, this has to be straight up and down, and this has to be straight across. So I went down, and then I went to the right. That's what these arrows indicate. Now, you don't have to do the slope triangle that way. I'm going to do it that way in this video. You might, if you want to, you can actually move it this way. You can go to the right and down. It'll come out the same. So it's kind of up to you. Some students even do it this way. I mean, they go up this way, and then they go this way. That's fine. There's many ways to do it. just so long as you make a slope triangle and it's a perfect right triangle. So what I'm going to do in this video is I'm going to start at my leftmost point here connected to my point to the right of it. I'm going to read it from left to right. And for this one, I'm just going to move down and then across. I find that the easiest. Again, there's other ways to do it. So I'm going to move down and then I'm going to move across this way. I'm going to put in arrows to indicate the direction I moved. Now, the change of y is basically the length of this segment. What is the length of this segment? Remember, we're moving down. So we just count it, right? So I start here and I'm going to count it. 1, 2, 3, 4. Let me do that again. Start here. 1, 2, 3, 4, 5, 6. So the change of y is 6 units, and we went down, so it's negative. So I'm going to replace the change of y here with -6. Now, what do you think the change of x is? It's this length from here to here, and I'm moving to the right. So I start here, and it's 1, 2, 3. And it's to the right, so it's positive. I don't need to show my positive sign. So the change of x is 3. There you go. That's your slope. It's -6 divided by 3. But we can simplify this. I mean, you can punch this into a calculator. What's -6 divided by 3? Well, let's see. 6 divided by 3 is 2. And then bring over your negative sign. There you go. And that's the slope right there. So the slope of this line is -2. And we knew it was going to be negative. If our answer is not negative, we're doing something wrong. We know it's going to be negative because it slants down from left to right. Let's try another example. So remember, the slope is the change of y over the change of x. And you know, I should have gone back. Let me go back here real quick to this here. Oh yeah, I did. I labeled my axes here. I just wanted to make sure I did that. Let's go back to this problem. Remember, your x-axis is this way. X, y. It's important to put that in. All right, let's do it. Let's find the slope of this. First of all, before I do this, is the slope going to be positive or negative? Hopefully you're thinking positive. It slants upward, right, from left to right. So we'll make our slope triangle. And again, I like to start with my furthest left point and move to, I read it from left to right. Again, you don't have to do it that way, but let's do it that way. So I'm going to start here and I'm going to go up. And then I'm going to move to the right. Now again, you could have gone to the right this way and up it would come out the same. I just like to do it this way. So let's see, what's the change of y here? From here to here, what's this length? Well, it's 1, 2. And it's plus because I'm going up. So the change of y is 2. Now remember, the change of x is across. Remember, y is up and down, so that's why this is the change of y. Y is up and down. The change of x is across. It's horizontal. You can see that from your x-axis. So what's the change of x? Well, I'll start here, right? 1, 2, 3, 4, 5. And it's to the right, so it's positive as well. So the change of x is this one, which matches with this, which is 5. There you go, you're done. The slope is 2/5. It's a fraction. I can't reduce this fraction, I just leave it like this. So the slope of this line is 2/5. I know my answer has to be positive because it's slanted from left to right in an upward direction. What about this one? Why don't you pause the video and see if you can figure this out. Welcome back. Let me write the slope formula. M represents slope. Change of y divided by change of x equals. Okay, I always like to start at I read it from left to right, so I'm going to start at this point. And you can move to the right and up, or up and to the right. I'm going to move up and to the right. My first movement tends to be up. That's how I learned it. But again, you can go this way and this way to make your slope triangle. But let's do it this way. So I'm going to go up and to the right. And I know my answer is going to be positive. Oh, I put my arrow wrong there. Do this again. So start here, slope triangle. There we go. And I like to put my arrows in to indicate the direction I'm moving. So what's the change of y? That's this one. Start here, 1, 2, 3, 4, 5, 6. It's positive. Change of x is this way, 1, 2. So the change of y is 6. The change of x is this one is 2. 6 divided by 2 is 3. So the slope of this line is 3. Again, put in your x and y so you don't get confused. So you know the change of y goes up and down and the change of x goes across. Let's try another one. What do you think? First of all, is the slope here going to be positive or negative? Hopefully you're thinking negative. It slants down from left to right. So we'll make our slope triangle. Let me write this in first. Again, I would recommend you pause the video and give this a shot. Alrighty, what's the slope here? Well, I'm going to start at my left point, move to my right point. I tend to move up and down first. You don't have to. That's just how I learned it. So I'll start here and I'll move down and to the right to make my slope triangle. So I've connected these 2 points. I'm going to put in my arrows so I move down. That indicates a negative direction. To the right's positive. Alright, so my change of y is 1, 2. I move down so it's negative 2. So the change of y is negative 2. And let's do the change of x. What do you think that is? It's to the right, so it's positive. 1, 2, 3, 4, 5, 6. So the change of x is 6, and that's my slope. There you go. Now, careful with this one. If you're taking the GED test or an algebra test, many times your teacher, or if it's multiple choice, this will be written in reduced form. This is not in reduced form. Another thing I want to show you before I reduce this is if you write the fraction like this, in other words, what I'm trying to get across is you can position this negative sign wherever you want to. Oops, I reversed the numbers, my bad. Hold on. Okay, so I'm just recopying this number here, but I want to show you something. These all mean the same thing. It doesn't matter where you position the negative sign. There's one negative sign in each one of these fractions. So if the negative sign's on the top, or if it's smack dab in the middle, or if it's at the bottom, all these fractions mean the same thing. When you're taking the GED test or a math test, they're going to put the negative sign right smack dab in the middle, just to let you know. And I'm going to do that at the end of this. But what I want to do now is just go ahead and reduce this fraction for you. I'm going to show you how I do it. So let's just keep the negative sign at the top for now. So I have negative 2 divided by 6. To reduce this, I am going to bring over my negative sign. Watch how I do this. There's more than one way to do this, but I'm going to bring over my negative sign here. And then I'm going to rewrite the 2 as 2 times 1. Because 2 times 1 is 2. Then I'm going to rewrite the 6 as 2 times 3. 2 times 3 is 6. And remember, I just brought this negative sign over. Well, when you're multiplying and you have the same number in the numerator as the denominator, or the same number in the top as the bottom, you can cross those numbers out. They're actually called common factors, and you can do that with multiplication. So we have a 2 on the top and a 2 on the bottom. I can drop those off, and I'm left with 1/3. And I just bring over my negative sign. Just bring this over. And there you go. That's your answer. But on a test, they're going to write it like this. They'll say the slope is. They will put the negative sign smack dab in the middle of the fraction like this. Same thing. There you go. So this is the best way to write your answer like this. Now this is correct. This is correct. But this is usually how you will see it written on a test. Let's try another one. what is different about this problem here? First of all, before I even do that, is the slope when we measure this, is it going to be positive or negative? Hopefully you're thinking negative, right? It's slanting from left to right in a, I'm sorry, getting ahead, I'm thinking of another problem. Not negative, forget I said that. It's slanting from left to right in a positive direction. So the slope of this line will be positive. So we know that for sure. Now, what's different about this problem? The points aren't showing, right? We're going to have to draw in points. So when you're finding the slope, you can pick any 2 points you want to. You need at least 2. So I'm going to draw in some points here. Now, real quick, when you're drawing in points, you want to pick points that fall where the grid lines intersect, right here. This is where grid lines intersect, or maybe a point right here. I mean, these aren't points on the line, but you want, and what I'm trying to say is when you pick points on the line, you want to pick points that fall right smack dab on the grid lines. You don't want to pick points off where the grid lines intersect. This you don't want to do. You want to pick them right here. So let me just be clear on that. When you pick points, they're going to be, maybe a point will be right here on the grid line, or right here on the grid line. You don't want to pick a point that's like right here in the middle of the square. So let's pick 2 points. There's a whole bunch. So what I do is I read the line from left to right. And I go, okay, let me find a point. Oh, here's one right here that falls right where the grid lines intersect. And I keep going. Here's another one. Keep going. Ah, here's another one. There's a whole bunch of them, right? Here's another one. Here's another one. So you should see that all these points fall where the grid lines intersect. You don't want to pick a point like right here. That's not going to help you. It's got to be exactly where the grid lines intersect. So just pick any 2 you want to. Doesn't matter. How about, let's say I pick, I don't know, how about if I pick this one? That's a nice point, and I'll pick maybe this one right here. That's a grid line. It's at the origin, but it's right at a grid line, right? So I'll pick those 2. All right. So the slope equals the change of y divided by the change of x. Well, what is that? Remember, x, y, right? Well, let's do our slope triangle. I go up and to the right. Right, I put in my little arrows to indicate the direction I move. So this is 1, 2, 3, 4. It's positive. And this is 1, 2. So the change of y is 4. The change of x is 2. Well, what's 4 divided by 2? That's 2. So you can keep it like this, but it's better to put it like this so the slope is 2. Now, I want to show you why it doesn't matter which points you pick. We'll pick another set of points. Watch. How about if I pick 2 other points? You're going to see we'll still get 2. Watch. Let's say I pick this point. How about this point and this point? And this point. I think it's better to pick points closer together. Watch what happens here. We'll do the same thing. You'll see we'll get the same answer. So m equals change of y over change of x. Let's make our slope triangle. Again, remember, you can also do it this way, but I'm going to do it like this. Let's see. Change of y, 1, 2. Boop. Change of x right here is 1 unit. So the change of y is 2. The change of x is 1. Which is just, well, what's 2 divided by 1? That's just 2. Look, you get the same thing. It doesn't matter which 2 points you pick. Once you reduce the fraction, you'll always get 2. I mean, you could even pick a point. You could pick a point here. Watch. I mean, this is such an important concept. That's why I'm going over it a little more in detail. I mean, you could pick a point here and here, and I'll do this a little more quickly. You could pick a point all the way here, here, and on one all the way up here. Watch. You do your slope triangle here. once you do it all, it'll still be 2. It's important that you understand that. Watch this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This way. This is 1, 2, 3, 4, 5, 6. And then you're going to go 12 divided by 6, which is also 2. So it's very important that you understand that it doesn't matter which 2 points you pick when you're dealing with a straight line. Once you simplify everything, your answer will come out the same. Let's look at 2 more. This is the special case. What's the slope of this? You should know right away when you see a horizontal line that's flat, right? This is me. Remember, ultimately, we're measuring inclination. This is flat. We're measuring steepness. What's the steepness of this line? It's 0. It's flat. So the slope of this would be written as m equals 0. Now, why is that mathematically, though? Let me show you. I know it makes my video longer, but let's use the same concept. Let's pick 2 points that fall on the grid lines. How about this point? I'm just picking 2 random points that fall on the grid lines. So how about this and this? Any 2 points. Remember, this is y, this is x. We're going to do the change of y over the change of x. What is the change of y here? Remember, the change of y is how much vertical distance there is. How much vertical distance is here? You can't even make a slope triangle here because the points are right next to each other. That's why this is a special case. You cannot make a slope triangle here. You have to visually see that the change of y is 0. There's no vertical movement here because the points are next to each other horizontally. So the change of y here, again, you can't make a slope triangle, is 0. And what's the change of x? Well, the change of x is in this direction, and I put this x in the wrong place. I apologize. Should be right here. Here's my x-axis. Sometimes I get going a little too fast here. So my x-axis is here. My y-axis is here. This is the line I'm trying to find the slope of. We already know it's going to be 0 just by looking at it. I'm just explaining to you mathematically what's going on. So the change of x is the horizontal distance between the 2 points. Well, you can see it. You can count it off. It's 1, 2, 3, right? So it's 3 units. Well, on a calculator, 0 divided by 3 is 0. You can punch this into a calculator, go 0 divided by 3, you will get 0. So that's mathematically why the slope is 0 here. Let's look at the last special example. What's the slope of this? We went over this at the beginning. Whenever it's vertical, straight up and down, the slope is undefined. Do not write 0. That's for a horizontal line. For a vertical line straight up and down, it's undefined, and you're done. But why? Let's look at this mathematically. This is x. This is my y-axis. It's the change of y divided by the change of x. Well, what's the change of y? Let's pick 2 points. All right, I'll pick, how about a point, I don't know, how about here? Remember, it's got to fall on the grid lines. You don't want to pick a point here. And how about right here? Okay, so what is the change of y here? Well, the change of y is the length of the vertical distance. Again, this is a special case. We can't make a slope triangle. So the change of y is the vertical distance, right? So it's 1, 2, 3, 4, 5, 6. So the change of y is 6. What's the change of x? That's the horizontal length of this line. Well, they're right on top of each other, so there is no horizontal distance. You have to just visually see that again. Again, you cannot make a slope triangle with this. So the change of x here, since they're right on top of each other, there's no horizontal distance. It's 0. Well, you cannot divide by 0 on a calculator. Let me just pull up the GED calculator, or on any calculator. Watch what happens if I punch this in when you divide by 0. I'm going to go 6 divided by 0. It says divide by 0, there's an error. So whenever you have a 0 on the bottom and you punch this in, you get an error. And in math, we call that undefined. So that's why the slope is undefined. Now, if there's a 0 on the top, it's okay. When you divide with a 0 on the top, you'll get 0 out for your answer. So that's the special case here. Well, I hope this was helpful. And again, slope is really important. And if you have a good foundation for it, you're going to do better on your GED math test and in your math classes. As always, thanks for watching my videos. Have a great day.